In this case, integration refers specifically to anti-differentiation. Integration is otherwise known as anti-differentiation. What's differentiation in calc? What have we been doing in the last 2 chapters? Oh my goodness, that's our problem. We don't even know what we're doing.
Taking derivatives.
Taking derivatives. Yeah, so an antiderivative is going backwards. It's undoing the differentiation process. We first found, let me backtrack a little bit. We have 3 different examples of y here. Y equals 2x cubed, y equals 2x cubed plus 1, and y equals 2x cubed minus 9. And I think we would all agree that if you took the derivative, each one of them would give you 6x squared. The problem is, how do I know which one is the right one if I'm given this? So we're going to be talking about how to find the what we call particular solution versus the general solution. And in essence, what we're doing is taking this and making this our new question and learning how to work backwards. It says, find the general solution to the differential equation. F of x equals 4x. F of x equals 2x. Differential equation is another word for a derivative equation. So we're saying that this is the derivative. 2x came from what function? Do you remember?
X squared.
X squared is correct. So I can say that capital F of x equals x squared. Here's why I'm using capital F of x. Okay, little lesson within a lesson. If I have capital F of x, its derivative might be denoted with a prime, f prime of x, or it might be lowercase version of itself. If I derivatize, that's not even a word. If I take the derivative of that, I can either write it as the second derivative of the capital letter, or I can write it as the first derivative of the lowercase letter. So this is the derivative process. Derivatives move left to right. But if I wanted to take my integral, if I wanted to do an antiderivative, then I'd be given something and working backwards. Well, we were just given a derivative equation, and we were told that it was f of x, lowercase f of x. So if I'm going backwards through integration, I'd have to label it capital F of x. Okay? Usually you'll be given this, and we would know our answer as this. Okay, so this is the general solution. This is what we call, well, this right here is a solution, but we're going to tag on this thing called plus c to make it the general solution. And here's why we use plus c. Again, I didn't know plus 1, plus 9. I didn't know where this was supposed to have come from. So I'm going to treat this as a general solution with a plus c, saying there could have been a constant here that when I took the derivative and got 2x, the constant would have disappeared. Right? The derivative of a constant is 0. So the answer to 2x becomes x squared plus c. And here's the general formula. When you take the integral, you're going to use the integral symbol. What's inside is called the integrand, and the integral symbol has on the other side the dx portion from our differential that we just did in 3.9. It might say dx, it might say dt, it might say, you know, a number of d fill in the blanks. But the point is, these are like bookends. This is on one side, this is on the other, and they both have to be there. When one goes away, the other one goes away. And again, here's a reminder that if you went from lowercase, you could take the integral and get uppercase. So before I go any further, do we understand why it's f of x lowercase to f of x uppercase? Okay with that? Do we understand that I have to put plus c on the end because I don't know if there was a constant there? Plus c will show up in all general solutions. If you were in class the day that we listened to Calculus Rhapsody and they were singing the calculus words to Bohemian Rhapsody, there was a part where they were like, don't forget the plus c, plus c, plus c. That's what they're referring to. You're going to have plus c every time. Keeping that in mind, if I was integrating nothing, I would at least have a constant. In other words, what's the derivative of a constant? Zero. So the derivatives are going this way, and now this is telling us to go this way with anti-differentiation. So it should be true that the derivative of c is 0. The derivative of kx plus c would be just the coefficient k. It froze on me. But this is the integration process, so we're moving in the other direction. If you have a constant in the front, a coefficient, just like in differentiation, that constant can be pulled out and I don't have to worry about it when I take the integral. It's also true that each individual part will get integrated separately. And the basic rule of integration, okay, let me remind you what the basic rule of differentiation was. The derivative brought the exponent out front and then subtracted 1 from the exponent. In integration, the exponent increases by 1, and that also becomes the denominator. So if this was x squared, it would become x cubed over 3. This was x to the 5th, that would be x to the 6th over 6th. All right. So rule number 4 just says we can integrate each of the individual pieces by themselves. Let's start with x squared. Increase the exponent by 1. And then that exponent becomes the denominator. We're going to keep the sign. 5 is a coefficient, so I'm going to ignore it. And I'm going to take x. And what would be 1 more for an exponent? 2. So x squared over 2. And because I want a general solution, plus c. Let's make sure that this makes sense for differentiation. If I bring the 3 down for the derivative with the 1/3, the 3 and the 1/3 cancel, and I'm left with x squared. If I bring down the 2 and the 2 cancel, leaving me 5x. Okay, so differentiation makes sense with this. Any questions so far? Okay, those are, oh, go ahead.
How did you figure out which rule to use? Just by like looking at the problem?
So this rule isn't necessarily one you use. This is just the expectation. For all general solutions. So, would you agree that this says x squared plus 5x plus 0? That's where your plus c comes in. There is always going to be a plus 0, so your plus c gets taken care of, okay?
Oh, okay.
This one just says if you have a coefficient or a constant number other than 0, then just make that into like a linear function. If this was 2, it would become 2x. But what we're working with is 3, 4, and 5 for this example. 5 tells us to raise the exponent by 1 and divide by that number. 3 tells us that the 5 can be ignored in the process. And 4 tells us to do them separately. So we're using three of the 5 different rules at the same time. It's not so much using one at a time. You're going to use a lot.
Okay, that makes sense.
So while we're at it, let's go back to this anti-differentiation process as it pertains to trig. Isn't the derivative of sine cosine? So it would make sense that the integral of cosine, which means go backwards from cosine, will give us sine. Isn't the derivative of cosine negative sine? So the derivative of negative cosine should be positive sine. This negative could show up in either side. As long as one of the sides is negative, we're okay. Tan to secant squared, secant to secant tan, and so on and so forth. I'm going to be completely honest with you. There's very few of these that I remember this way. What I remember is how to read this sentence. I read this as, whose derivative was cosine? That's not what it's saying, but that's how I read it. Whose derivative was cosine? And I know it to be sine. So instead of learning 6 integrals, I learned my 6 derivatives and knew that integrals were backwards. Okay? All right, so let's do a few of these examples. 3x to the 4th. Who thinks they know what 3x to the 4th is going to turn into?
Would it be 3x to the 5th over 5?
Yes, it would. Who's got a thought about negative 5x?
Would that just be 5 x squared over 2?
Negative 5x squared over 2. What about 2? The constant 2. 2 was the derivative of what? Nakai, you unmuted and then you muted. I didn't hear anything. Oh no, I can't hear you.
Would it be 2x?
It'd be 2x. And then, like I was telling Aiden, isn't there a plus 0 stuck in there that we're not seeing? So because there's a plus 0, we can generalize the solution and say plus c at the end. Now real quick, let's take the derivative to make sure that that is the correct place it came from. The 5 comes down, cancels with the 5, leaving me 3x to the 4th. The 2 comes down, cancels with the 2, leaving me 5x. And this, the derivative of 2x, is just 2. And the derivative of any constant is 0. Number 2, the constant or the coefficient rule says that that 4 has no bearing on the integral of sine. By the way, if you want to draw the symbol, it's really just like a soft, long S. What's the derivative, or whose derivative gave us sine?
Cosine.
And what is the derivative of cosine?
Sine x plus c.
Be careful. What's the derivative of cosine?
Would be negative sine.
Negative sine. So since I don't see a negative, I have to put it with my answer. Does that make sense? The negative has to be somewhere, and if it's not part of the integrand, then it has to be part of the answer. Who gives us a derivative of secant squared x?
Is it sine x, cosine x?
No?
Tangent?
Tan is correct. There you go. Megan had it too. And then negative 1 is the coefficient of negative x. Plus c. These are capital C's, by the way. Make sure that yours is a capital C as well. Number 4 behaves a little bit differently. It's written with the x to the 5th in the denominator. And just like when we take derivatives, we should look at this as if it was kind of like a polynomial. So I bring x to the 5th up, but by doing that, it changes the sign. Notice if I have an integral symbol, I have to have dx on the other side. So somebody else that maybe hasn't gone yet, what's one more than negative 5? Negative 4 is correct. And that also becomes our denominator. In a testing situation, you can leave it like that, but if you so choose, you can also move what's attached to the negative exponent to its rightful position. The negative can go either in the top, the bottom, or out front of everything. The 4 stays, and x to the negative 4 becomes x to the 4th in the rightful position. Again, on a test, you can keep it like this. Try number 5 on your own. Who thinks they have the correct answer for number 5? Wants to give it a shot. By the way, Nakai, if your sound isn't working, if you sign out and then come back, sometimes that works. Should I let him in when he knocks? Be like, oops. So somebody else, while we're waiting, who thinks they did number 5 correctly and wants to give it a shot? Oh, do I? Yeah, I will. Did it work, Nakai? Did it work? Can
you guys hear me?
Yay! I'm a tech whiz. So somebody, who's going to help me with this?
X to the 3/2 over 3/2 plus c.
Beautiful. So this is really the integral of x to the 1/2 dx. We know that one more of that would be x to the 3/2 over 3/2 plus c, but you shouldn't have fractions within fractions. So what I would do is I would write, and watch this very carefully, I hope I have everyone's attention. I would write x to the 3/2 over 3/2. You're going to multiply by the reciprocal, but I say over 3, that reminds me to put the 3 in the denominator, but the other one gets moved to the numerator. X to the 3/2 over 3/2 plus c. What do you think? Integration is so rad. It's totally tubular. It's pretty much the best thing we've ever done today. Like, for real. We just completed a couple examples that needed to be rewritten in order to integrate properly. By rewriting, the complicated terms became much more manageable, and the antiderivative was able to be found fairly easily. In other instances, the simplicity of the integration rule might not first be seen. However, utilizing the rewriting process appropriately can alleviate a multitude of stresses. So we see a question like this, and what I notice is that I have a single term. I hesitate to say monomial because a monomial is a polynomial, and a polynomial only has whole number exponents. But I have a single term in my denominator. I have a lot of liberty here. I can either break up my integrand into 2 separate fractions with square root of x in the denominator, or I can bring it up and distribute it through. How you do this is up to you, but what I have noticed more commonly is people writing it this way. I brought x to the 1/2 up, so it becomes negative. X plus 1 is the entire numerator, so x, when it's brought up, needs to be applied to the entire numerator. But good news, that numerator did not have an exponent on it other than 1. So I can legally distribute. Notice I write the integral sign every time. What would be the new exponent if I multiplied x to the negative 1/2 with x to the first power?
Would it be 1/2?
Yes, it would. You add the exponents and you get a positive 1/2. If I distribute this with the 1, then I just get itself. Nakai already answered for us the integral of x to the 1/2. He said x to the 3/2 over 3/2. And what would be x to the negative 1/2?
X to the half over 2.
So you're partially there. It would be x to the 1/2 over 1/2. The fraction's denominator gets moved up. What are we missing?
Plus C.
Plus C. Good. Good, good. The second example looks a little bit like a chain rule. There is no chain rule for, I mean, there kind of is a chain rule for integration, but we won't learn it till section 3.5 or 4.5, I think. So what would you do with t squared plus 1 squared that would help us integrate really easily? What does that mean?
Just multiply itself.
Yep. T squared plus 1 times itself. I can do this in the integrand symbol. I might as well. T squared plus t squared is t to the 4th. T squared plus 1. T squared plus 1, or times 1. And then 1 times 1. Notice I don't have parentheses around this. I don't really need them all the time. As long as it's boxed in with the integral sign and the dt, I just know that everything is going to be integrated with t being the variable. If that said dx, then we would have a problem. So all these letters need to match. All right, let's hear it. T to the 4th. I think this one has Kayla's name on it. Yep. Do you want to keep going? Plus what plus c? Yes. So I'm glad you said that because that's where we need to be careful. We know that it's quote unquote x, but x is going to change depending on the variable that we're working with. Yep. Job. These clip-on earrings are hurting my ears really badly right now. And I don't know if you guys can see their zebra print. Holla! Next one, on your own. Any thoughts? First, I'll ask what we could do to answer this question.
You could bring the bottom term up and distribute it into the first term.
What would it look like if it was brought up?
It'd be 2x.
Be x to the negative 2.
Yeah, x to the negative 2. Moving up and down changes the sign. And since there's no parentheses on that, I can distribute. Negative 2 plus 3 becomes 1. And that looks a whole lot simpler to integrate than what we started with. So Cordell, what would you get for an answer from this integrand?
I got x squared over 2 plus 3x to the negative 1 over negative 1 plus c.
Very good. I'm going to take a second just to rewrite this as x squared over 2 minus 3 over x. Notice this is not 3x to the negative 1. It is just x to the negative 1. If I wanted parentheses, they would be there. In a test situation, you could leave it like the last step. However, I do hope that you would put a negative here instead of having a plus negative, or a minus here instead of having a plus negative. All right, keep going. Try the next one on your own. This question actually resembles the last one quite a bit. There isn't going to be a negative exponent, so it's not going to be the same in that regard. But what is the exponent of the first term? What would that turn into?
1/3.
1/3 is correct. And again, because these parentheses have a power of 1, 1 is able to be distributed into. Any other power is a no-no. What does that result in? Karen, you're mesmerizing right now. I always wanted to do the pen thing. I can't. How do you do it? It's crazy. I don't get it. Like, you just have it. do I get when I distribute? What's my new integrand?
X to the 4/3 minus 4x to the 1/3. Yes.
Very good. Because if this is 1, 1/3 plus 1 is 4/3, or 1/3 plus 3/3 is 4/3. If you're not sure how to do that, please use the calculator. 1/3 plus 1 is 4/3. One more would be the same, like when we took our derivative, we subtracted those and we said 1/3 became the new exponent. Now add them for the new exponent. This becomes x to the 7/3 over 7/3. I bring the 3 back up. X to the 1/3 becomes
4/3.
over 4/3. And this doesn't read 43. This is 4 times 3, which means I can cancel those. Final answer. You could write 3/7 x to the 7/3, or you can put 3 with the x in the numerator.
So would it be wrong not to simplify and leave it negative 12x over 4?
I would say yes, because it's an easy simplification. I would just hope that if you saw negative 12 over 4, you would know that to be negative 3. Okay? Questions thus far? You're doing a good job. Okay. I'm trying to remember back in the day when I wrote option 1 and option 2 as to what I was looking for. I don't know. I should have just left it blank. What do you think for sine x over cosine squared x? Actually, I'll help you with option 1. One way to solve this is to let cosine x equal u, and the derivative of it equal du. That's less than 4.5. So we're not there yet. We're going to have to figure out how to manipulate our integrand so it's something that we can integrate. What can I change? Sine over cosine.
It'd be tan x over cosine x.
Oh, I like where you're going with this. So what I'm thinking you did was separate this. Did you do that?
Yeah.
It wouldn't be times cosine x though, would it? What's that become?
Is that secant?
It is. We're not used to seeing tan x, secant x, but we are used to seeing secant x, tan x. And since multiplication is commutative, I can just switch their order. Whose derivative, when I ask you, will you tell me secant x, tan x? The derivative of blah is secant x, tan x.
Secant squared x?
You gave me another formula's derivative. So the derivatives were cosine, negative sine, secant tan, negative cosecant cotan, secant squared, and negative cosecant squared. Which one gave us secant tan? Which one of the basic six?
Just regular secant squared, or just regular secant x.
Just regular secant x. This is why I cannot harp on you enough. You have to know your six trig derivatives unquestionably. You have to be able to know them immediately and be able to recite them immediately for this very reason. Integration becomes incredibly difficult when you don't have the tool belt from derivatives. So if you haven't done so, go and memorize those six derivatives quickly. I want them by tomorrow. Maybe I'll give you a little quiz. We'll see. How is this next example different from the ones that we've talked about up to this point? What word do you see differently here that might stand out?
Initial condition.
Initial condition. That goes hand in hand with what?
Particular solution.
Particular solution. Not to be confused with general solution. A general solution has plus C. A particular solution has plus whatever that specific number is. And we're going to be able to figure out what that specific number is with the initial condition. By the way, this is another way to write when the x value is 1, the y value is 0. All right, so capital F prime of x is equal to 1 over x squared. And we're asked to find the solution to this differential equation. In other words, they're asking us to integrate. How would you integrate this? What steps would you follow? What? You scheduled it for the middle of class? Mr. Sullivan. All right, you won't be back by the end of this because we're going to finish this before lunch. But good luck. You're welcome. What are we going to do here?
Put the x squared up top and it becomes x minus 2, or x to the negative 2.
You got it. Whose integral or antiderivative answer is
Would it be negative 1 over 1?
Yeah.
x to the negative 1 over negative 1. And normally we would write plus c. By the way, if this is the integral, how would I note the integral if I'm given capital F prime? What would the integral answer be?
Would it be lowercase f double prime?
If you're going lowercase from a capital, you're moving this way into derivatives. How can I undo f prime in capitals? To go
Just
back.
capital F.
Just capital F of x. Okay? All right. Let me rewrite this. Capital F of x is equal to negative 1 over x plus c. I'm told that 1 is my x value and my y value is 0. So what's the value of c?
One.
1. If I take this -1 and I move it to the other side, it becomes positive, so c is 1. Here's the final answer. Therefore, my particular solution is -1 over x plus 1. There's no plus c in this answer because I know what specific constant needed to be there for this initial condition. Okay, so the process would be find the general solution, plug in what you know, make sure you plug in your x value and then your y value becomes the 0. Solve, but this isn't the answer. Plugging it into the final equation is the answer. Just like that, we're almost done. How does integration show up in real life? Well, we've already talked about the position function, and we're going to talk about it more specifically now that we have the integration process to include instead of just differentiation. We talked about how the position function is usually listed as s of t. The derivative of the position function is equal to velocity. And the second derivative is equal to acceleration. We've talked about this already. On the other hand, derivatives are moving to the right here. If I wanted to integrate, I would move to the left, and here's what I know. The integral of, or the antiderivative of acceleration is velocity. The antiderivative of velocity is position. Okay? The derivative of position is velocity. The derivative of velocity is acceleration. The antiderivative of acceleration is velocity, and the antiderivative of acceleration is, or of velocity is position. The second integral, the double integral, would mean moving over twice. The second derivative would mean moving over twice. Okay? Suppose a ball is thrown upward with an initial velocity of 48 feet per second from an initial height of 100 feet. Find the position function given the height as a function of time. Now, I could just throw out the position function general formula for you, but we're going to actually discover it by paying attention to one thing, and that's feet. Any of you take physics right now? Or have you taken physics in the past? Then you learned in physics that the acceleration due to gravity was negative 9.81, I think, meters per second squared. Stop me if that doesn't sound familiar. That's meters, but if we're talking about feet, then it's negative 32 feet per second squared. We did talk about this in class with calc, but I can't remember about physics. How do I find the position function from acceleration?
Aren't you just finding it from the velocity though, not the acceleration?
I will be finding it from velocity, but I have to get to velocity. I don't have velocity yet. So you're correct. I would move this way, but I have to move here first. So I'm going to be taking an integral and then taking another integral. Okay? velocity is the integral of negative 32 dt. What does that make velocity? What's the integral of negative 32? What's the integral of any constant other than 0?
It'd be negative 32x.
Or, in this case, negative 32t plus c. We know we have an initial velocity of 48 feet per second. What does the word initial mean?
Starting velocity.
Starting velocity. That means your velocity is 48 when time is 0. 48 when time is 0. What's C?
48.
Okay. All right, so here's what I know. The velocity equation is negative 32t plus 48. So far, so good? How do I find position? What do I do to velocity to find position?
Have to take the integral of velocity.
Yeah, one more integral. Okay. The integral of negative 32t is negative 32t squared over 2. The integral of 48 would be what?
48t.
Plus c. Now these are two different c values, so I'm going to use a subscript of 1 for the first one and a subscript of 2 for the second one as to not confuse them. I'm also told that my initial position, my initial height, is 100. 100 is my answer. 10 is my time. Oops. What's C2?
Put in C be 100 then.
Therefore, my position function is S of t equaling negative 16t squared plus 48t plus 100. So generally speaking, what we know to be true is that this is always going to be negative 16 because of the negative 32 that was established from gravity. Okay, if I took the derivative of this twice, I would get negative 32. That's not going to change. Initial velocity goes in the middle coefficient. We call it V naught. And initial position goes in the last piece of the polynomial. We call it S naught. That's true for all position functions. So velocity, initial velocity, if it's going up, is positive. If it's going down, it's negative. And our height goes on the end. Question says, when does the ball hit the ground? So when implies we're solving for what? Time. And hit the ground, is that a velocity or is that a position?
A position.
Position. What is the position when you're on the ground?
0.
0. Position is just another way to say height. What's our height when we're on the ground? So what they're telling us to do is set the equation equal to 0 and solve for t. By the way, why is this coefficient in the front negative?
Because the ball's falling.
Okay, and if you ever see, especially in pre-calc, if you see the position or as you see the movement of a ball in air, we see it go up, we see it come down. It's an upside down parabola. But also, in order to have gravity pulls down, so it has to be a negative number right from the beginning. All right, 16 is divisible, or 48 is divisible by 16, but 100 is not, right? No, not nicely. So what can we use to solve this if it doesn't factor? What do we use to solve a quadratic?
Quadratic equation.
Well, that is a quadratic equation.
Quadratic formula.
Quadratic formula. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, you can't do both plus or minus at the same time, so we do plus first and then minus. Couple clicks on the calculator, and this is what I get. What conclusion can you draw?
That you make
Yeah,
time. Yeah, you can't use a negative time.
Yep, can't have negative time. So my answer is 4 and some change seconds. Takes me 4 and some change to hit the ground. Okay, I'm going to write that. It takes 4.415 seconds to hit the ground. Usually the question that goes along with this is, how fast is it going when it hits? It's not asking that here. I thought it would. But what would you do if it said how fast just before it hits? What do
Could you
they?
do something like looking for final velocity?
It'd be velocity at that time. velocity at 4.415 seconds. Well, we have a velocity formula right here. Negative 32 times 4.415 seconds plus 48. I know I wrote 4.415 here, but I'm not actually going to write it out. I'm going to do negative 32 times my answer plus 48. And I get negative 93.30 feet per second. Why is it negative?
Because it's, the down acceleration.
It's falling. Why is it not 48 like the initial velocity? Does it make, oh, go ahead. Say that again.
There's acceleration
Be-
with gravity.
Because there's acceleration, the longer that I'm in movement, the faster I'm going to be going. And I'm only throwing it upwards at 48. Eventually, it's going to get to a point where the velocity is 0, and it starts to fall back down. So, keeping in mind a parabola motion, let's say it looks something like this. If we're going 48 feet per second here, we're going 48 feet per second here. But in the motion from here to here, it's going to continue to move faster, faster, faster because our slopes are getting steeper, steeper, steeper. And slopes come from derivatives, and the derivative of velocity is acceleration. Good. Final question. What's the max height of the ball thrown? Here's what we know. Let's finish this real quick, and then we won't have class after this. You can dip out, okay? I don't know why I just used dip. That makes me sound really weird. Max height would be what in relation to this formula?
The 100.
No, it wouldn't. But the 100 is a good guess because that is a height. But remember, that's where I threw it up from. So it's definitely higher than the 100. What's true for maximum points? What did we just do in chapter 3? What's special about the max point? And what's true about the derivative? Yep, but what's the slope there? 0. So if we want a max point, we take the derivative and set it equal to 0. Negative 32t plus 48 equals 0. Negative 32t equals negative 48. .5 seconds. Now hold on. If you turn this in for an answer, I'm going to look at you like, what? You're telling me the max height is 1.5 seconds? What do you think we do with the 1.5 seconds to figure out the max height?
Plug it back.
Yes. So now, what is S of 1.5? This is why it's important to really think through your questions, because a lot of us would just take the derivative, set it equal to 0, and think that we were done. Notice I'm still using equal signs because it was actually equal to 1.5. That's not a rounded answer. $136 what?
feet.
Feet. Okay, it's slightly more than the 100 because we threw it up from there. There are blank solutions to an antiderivative. What do you think? How many solutions do you think there are? Take 2x. 2x, the solution would be x squared plus 1, x squared minus 5, x squared plus 10, x squared minus 5, x squared. Say that again?
Is that infinite solution?
Yes, it is. There are infinite solutions, so it's important to use plus c for your general, because it could have come from any equation that had a constant at the end. We just didn't know what constant it was. So x or 2x has infinite solutions, and it's not until we use the initial condition that we can figure out the particular. So we're going to plug in the initial condition for the particular solution. What kind of a role did the coefficient have when we integrated? Like if you integrated 3x to the 5th, what purpose does that 3 have? Actually, let me do 3x to the 3x to the 15th.
Isn't it just a placeholder since it will just stay out front?
It's basically pointless, isn't it? X to the 16th over 16 plus c. The role of the coefficient is basically no role. It's just chilling there. The integration of an algebraic term requires blank, but does not work for the power of blank because blank. The integration of an algebraic term requires adding 1 to exponent and dividing by it. But it does not work for the power of something. What exponent do you think this would not work for? What exponent could not be added 1 and then divided by that number?
Would it be -1?
It would. Because you can't divide by 0. So this works for every single exponent except -1. And for those going into Calc 2, we'll talk about what happens with -1. That's where we start to get natural logs. The relationship between position, velocity, and acceleration, I just want you to do this. S of t, derivative is v of t, derivative is a of t, and then backwards, what would I put on those arrows?
The I.
The I for integration. Very good. That's it.